Namespaces, as presented by Eric Snow. Please make him welcome.
Namespaces, a very important thing, but first I want to thank all of you for coming and for being part of the Python community that's really awesome. Everybody give yourselves a round of applause because this conference is great and this community is wonderful. So today we're going to talk about namespaces in Python, which is an important thing. First, I work for a hardware company, Fusion.io. You can reach me there. My slides are online. Aside from the place where the conference is putting them, it's a Google Doc, and you can get it from that URL. Namespaces in Python, very important thing in Python. They're one honking great idea, and we have done more of those. I can't really say more than that. So today we're going to talk about what do we mean by namespaces, what do they look like, and basically how you can make use of them. First off, what are they really all about? So, you get this nebulous idea of a set of things that you care about, and you put names on all of them, unique names so that you can identify them. Namespaces. Relatively straightforward. And one key thing about namespaces is the way that we can nest them. So if you just have a bunch of names pointing to values, it's a namespace. But if those values can themselves be namespaces, then we can capture a much larger set of data without having to expose the whole set in one giant namespace. You run into this problem with some languages where you don't really have that kind of nesting. I mean, if you look at versions without nesting there, you could make it work, but it's just, you're going to be less able to express what you want in a succinct manner and organize things really well. So you just have to be careful when you're nesting not to nest too much. But again, the Zen, if you live the Zen, you're already living that. If you look at C, which doesn't really have namespaces like Python does, we get the same effect in like the C Python code. You get namespaces by prepending various names right onto the name, and that's one way of accomplishing namespaces. You could do the same thing in Python. But if you looked at, if we were to use dotted access instead, it's a little more familiar, easier to read. So namespaces are themselves kind of an abstract idea. But if we want to get more concrete, we could use what we call namespace containers. So these are the concrete implementations of namespaces that we use all the time. In real life, a dictionary is a namespace container. But today we're going to talk about 3 different kinds of namespace container that I found really useful. And one key thing is that the namespace containers say a lot about what kind of namespaces that they're holding. So when I think of a mapping-based namespace, then I'm thinking of more of a volatile and flexible namespace that could be changing all the time, whereas attribute-based namespace, like our object in Python, is more stable. It may change, but really it's mostly not going to. But property-based namespace says to me, this is not changing. It's fixed in stone, the names, the values, it's not changing. So I'll tell you a little story. Last year I was working on the sys implementation in Python 3.3. And in the discussions, we were working out really what type that should have. And I found that I really wanted sys implementation, the type of it, to express what was in it, what kind of namespace it was containing, to really communicate that nature. So I looked at dictionaries and mapping types, and they just didn't really seem to capture the idea that Systa implementation wasn't going to change very much. You see a dictionary, you think, oh, well, it might be changing. But name tuple, which was on the table, it was also really rigid, like this will never change. And I didn't want to communicate that either. So we looked at objects, and particularly subclasses of objects that have namespaces that are more mutable, that it fit a lot more closely to what I was thinking of for the meaning of sys implementation. So we added a new type, which is basically just a subclass of object that adds a nice repr, and that's what got used for sys implementation. So the whole point of that I learned from this experience is that you want the type of your namespace to really communicate what's in it. And so we're going to spend some time talking about these three. And hopefully by the end, it'll be a little more useful to you. You'll look at namespaces a little differently. First off, mapping-based namespaces. Like I said, they're more flexible and changeable and really a lot more raw. If you look in Python, there are a variety of instances of this, and these are some of the important ones. And you'll notice like os.environ isn't actually even a dictionary. It's more of a mapping around this other underlying namespace. But it still provides this mapping interface to the underlying namespace. So, mapping-based namespace doesn't just mean dictionary. So if you look at the syntax, it's one that you're already familiar with, dictionaries and all mappings. So in Python, there are quite a few different types for mapping-based namespaces that you can use. And these aren't even all of them, really. So, and there's some really interesting ones. I'd really recommend later on, when you've got nothing else to do, and you just pull up my slides just because, and you go through and you can look at this slide and look up all these different namespace types and try them out. So if you look at how mappings work under the hood, the interpreter is going to be calling these special methods on the objects and, well, on the classes and basically on the objects. And so if you want to have your own mapping type, you're going to implement these methods on your class. But one nice thing that we have in Python is collections.abc, which is a module that has a whole bunch of abstract base classes for containers and collections. So two of them I have here, kind of munched together. Mapping and mutable mapping provide that API that I was talking about here, as well as mix-ins for providing a bunch of the other functionality of mappings, which is nice, because then you don't have to implement all of it. You can implement part of the interface, and you get the rest for free. For instance, here's an example of making a mapping that we can use for a mapping-based namespace. And really all I had to implement, because I'm inheriting from the mapping class of collections.abc, is the length, iter, and getItem methods. And then mapping provides me the rest of the mapping interface, which is really nice. Some of the really neat things, there's all sorts of things that maybe you're not familiar with about mappings. And here are a few of them. For instance, that first one there lets you pass in two different dictionaries or other mappings into dict, and it'll merge them all into this new dictionary that you're just creating, which is kind of neat. There are a few other little gems you find in Python regarding mappings. So moving on to property-based namespaces, like I said, they're more fixed in place. And you see that and you can expect that it's not going to be changing. And so really there's mostly a property that's aliasing some underlying value in the underlying namespace of this object. In Python, we have quite a few uses of property-based namespaces. And here's a couple examples of them. These are both not named tuple, but they're actually struct sequence, which is basically the C version of named tuple. So about the same thing. Now, named tuple is, if you boil it down, what it amounts to is a subclass of tuple that then has properties mapping onto the indices of that tuple. Now, the named tuple method out of collections that you use is based on this principle, but it builds it dynamically for you. It makes it really nice. But the general idea here is just that you have these properties indexing down into the underlying namespace that's hidden away. In the case of named tuple, you can still use the underlying namespace pretty readily, though. So if we want to build our own read-only proxy using property-based namespace instead of the mapping-based one like before, we can do a similar thing here where we are having an underlying object and we're exposing through properties the attributes there, and so we've made this property-based namespace out of that. Attribute-based namespaces are probably where there's the most action and probably the most interesting discussions that we can have. Think of them as stable, but they're not fixed in place like property-based. So you're still talking about a proper name associated with the value, not quite so raw as mapping-based. And underneath, the interpreter is going to be using these methods off of your class to implement the dotted access that we use in Python. One of the key methods there is getAttribute, because it isn't straightforward as simply looking something up on the underlying namespace of the object. What's going on is there are a whole bunch of steps here and involving descriptors. And so real quick, before we talk about this more, I want to talk about descriptors, just give a really high-level view that descriptors are objects that have these methods. And the interpreter is going to use descriptors when it does that lookup in a special way using get and set and so forth. So there's a subset of descriptors called non-data descriptors. They're ones that only implement the get. And then data descriptors also implement set. So you use descriptors all the time when you use things like property class method and static method. So back to this, a data descriptor, which implements both get and set, we're going to getAttribute first tries that. It looks to see if there is one. And if there is, then it calls the get on it. And that's what you get back. If that's not there, then it's going to pull it from the instance if the instance has a dict. And then if it doesn't, then it's going to try non-data descriptors. And after that, it's going to try getAttribute if there is one. And then after that, you're going to get an attribute error. So the key thing there, and this will tie in to something we'll talk about a little later with how things resolve during execution. But when it looks, getAttribute looks for the descriptors, and for getAttribute, it's going to be looking on the class of this instance. And if it doesn't find on the class of the instance, it's going to look on the parent of that class, and so forth, all the way up to the base object type. And the way it looks is it goes up the MRO, which is the method resolution order. But basically, it's just the chain of classes from inheritance. Now, if we were to use that same example again of a read-only proxy, we can use the getAttr method there, which is, like we said, it's the fallback. When it can't find it anywhere else, it looks in getAttr. So we'll just use getAttr there, and pass it through to the underlying object. Which is really straightforward, the shortest one of the 3 so far. So objects, there are a few attribute-based namespace types that you'll find in Python. These are some of them. Go back and have a look at them, try them out. Some really neat things. Qual name, which is something new in Python 3.3. It's like the name of the class, except it exposes the whole chain of parents in the lookup chain. So where it was defined and where, if it was defined in a function, where that function was defined, if it was defined in a class, also, that parent class, the whole chain of them. You can look at the dunderqual name attribute on classes and functions and have a look at that. And it's actually really useful when you're talking about namespaces. So again, the key thing here is that we're going to communicate the nature of namespaces. So use the one that fits what you need. Now, objects are a big deal in Python. And they're all about namespaces. They contain namespaces. They often have namespaces, the dunderdict. If we look at a simple namespace, if we call vars on it, that just looks up the dunderdict and gives it back to us. And then we can check, and it says, yes, the dunderdict is what got returned by vars. The underlying namespace of that simple namespace object is the dunderdict, a dictionary. Now, what's interesting is that the base object type does not have a dunderdict, because if it did, then everything that inherited from it would also have a dunderdict. And that really wouldn't work for a lot of the built-in types that we have. But if you make a class via a class definition, then it automatically gets a dunderdict unless you tell it not to. So what's nice is Python provides a whole bunch of different helpers that let you deal with object namespaces. One interesting one is the vars built in, that what it does is if your object has a dunderdict and you pass it in, then it'll expose that for you. Now, most of the built-ins don't have a dunderdict because they don't need one. Function objects do. Module namespaces are also exposed as dunderdict, and class namespaces are exposed via dunderdict, but it's actually a read-only proxy of that namespace. You can mess around with metaclasses to customize that somewhat. You've probably heard of slots. Slots are a way of, instead of having a dict, having just a fixed namespace, and it's actually hidden away and exposed via descriptors. During execution, so this is where namespaces come into play in a different aspect. That when we have, you can take an object and use dotted access on it to get something out of its namespace. And like I said, it'll use the method resolution order if it needs to look something up that way. Classes and objects basically have the same lookup mechanism because classes are just objects. And special method lookup, there's, for what the interpreter is doing, it'll often cheat a little bit on how it looks up the dunder methods that it needs to execute these underlying APIs. So often when you're programming, you have variables that aren't anchored to any other object, and those get pulled out from a little bit different mechanism. in a function, and basically all execution is happening through the same function mechanism. So in CPython, we have execution frames, and these frames have locals and globals and built-ins. The locals, you can access those if you're in a function or even in a module or wherever. You can access those using the locals built-in. It'll give you back the dictionary, the namespace of the currently executing block. But for functions, if you make changes that, it really doesn't affect the actual namespace. But that's okay. You probably shouldn't be changing the namespace dynamically like that in a function anyway. But then if it doesn't find in the locals, it'll fall back to non-locals or closures, if there are any. And from there, it'll fall back to the globals, which are the globals that were associated with the function when it was defined. And then after that, it falls back to the built-ins, which are effectively the interpreter top-level namespace. So talking about that, you have those built-ins, which are kind of an implicit top-level namespace, and an explicit one would be sys.modules. When you do import, that's the top level where names are getting stored. So for instance, if you had some module named Mordor, that you could do sys.modules at Mordor to access it. Now, what's interesting is you can use the import statement to access that same namespace. So, here's a silly example, and this is actually on the package index, Mordor. So access via the import statement. You could even think of the ID method, or the ID built-in as exposing a global namespace. So wrapping up, Python provides some powerful APIs for interacting with the namespaces of objects and namespaces in general. There's also some key attributes that you should be aware of when you're thinking about object namespaces. Also, Python provides a bunch of really powerful helpers that let you interact with object namespaces and otherwise. And finally, the whole deal here, the main point is that you need to have an awareness of what you're trying to capture in your namespace and pick the appropriate type. So we've talked about mapping-based, property-based, and attribute-based namespaces. And so when you're thinking about what namespace you're going to use, consider what you want to communicate by the type that you're using. And Python provides a rich set of tools that you can use. And thank you very much.
So if there are any questions, please approach the microphone in the aisle here or come and collect mine. Now I think, Raymond, do you have one?
Yes, I do.
I'll just pass you this mic then.
I have a couple. So what was it about system implementation that needed to be volatile, that needed to be assigned to? It seemed like that would be a tuple of constants. Why did you choose a namespace for that? A simple namespace.
Because we wanted to communicate that it wasn't fixed in place. It wasn't some set structure that was going to persist forever. It didn't have order to it. It didn't have some fixed set of things that was never going to change.
So you didn't want to name tuple because you wanted to be able to change the length later, add attributes, but you weren't looking actually to make the attributes mutable.
Correct.
Like, you didn't want to be able to take the implementation, change it from CPython to DPython, right in the middle.
Right, and that's
I would have expected that to be constant and not settable.
Yeah, and it's mostly a case of, trusting that people aren't going to mess around with the stuff in the sys module. And if they do, then, they're consenting adults.
They deserve what happens to them.
Yeah.
I understand. And the second one is, why did you have to introduce simple namespace? Could object have just been made mutable and some people could make an instance of object and have a simple namespace? Why did it need a separate class?
Well, the key thing there is that, that the base object type, because it's the base for all objects, that it doesn't have a dict because then it would cause the rest of the objects, or the other types to have a dict. And so in order to get a dict, which was the simplest way to do that, we simply subclassed object. And it also gave us a chance to have a nice wrapper on it.
So it seems as though there are no more questions. This has been one honking great talk, so please thank Eric Snow.